My name is Eric Woodroof. This is a little hobby I've been working on the last few years. This is a net zero greenhouse. You'll notice it's earth bermed and also has a lot of water collection and some interesting, we call it cooling technologies inside. Why should you watch this video? Because you're going to learn about a lot of mistakes to avoid. A lot of expensive mistakes. So hopefully that'll help people. I think you will get some cool insights about some of the technology. We did some cool things with water pressure boosting or friction reduction. We have a cold sink in that thing, which also helps the geothermal do its magic. And I think you'll enjoy just some of the things. So please do, and here we go. So flashback several years, and you're looking at the reason why we needed to build a greenhouse. Because my wife, I love her, but she's got an obsession with plants, mostly ornamental plants, and we needed to get these outside the house. And that's why we wanted to build a greenhouse. Okay, so why on earth would you put a 1,200 square foot greenhouse into a hill? Well, that way you'd be capable of growing pesticide-free food all year long, winter, summer, everything. Now, what are we actually growing in the greenhouse? I think it's seeds and ornamental plants. I have no idea, but we have the potential. The other thing about passive design is that it uses far less energy and therefore is much less expensive to operate. No fossil fuels in the winter, no air conditioning, etc. And it's more sturdy if the winds get high. The building is oriented east-west, so the south-facing roof is what you're seeing right there, and that is a typical design for a greenhouse. As far as the envelope goes, all of this is custom made, which is more expensive. Don't do that if you can avoid it. On the left, you'll see a garage door and a human door. Those are the only things that are kind of off-the-shelf technology. Everything else was custom. The cold frames and these large movable doors up front, which we use plexiglass because that allows you to see in and out for safety and also just enjoy it. But you'll notice in the far right back there, there's a little red fire extinguisher, and it's important just safety-wise. If you ever had a fire, you know, the entrance is one direction. You'd want to be able to kind of get out, so the fire extinguisher might be helpful. All of this started with a blueprint, which had to be adjusted. Most of this, as I said, was on-the-fly drawings. I learned about steel beam spans and all kinds of stuff, but came up with this concept and incorporated some sun angles to make sure that it would get the right amount, but it did require some trees to be cut. So I can't say the construction process was carbon neutral. We did our best. We had heavy equipment. We did run into rocks. We had to make adjustments. But ultimately, even after the design adjustments, the building still was 40 feet wide on the inside and 30 feet deep. And that creates a tremendous amount of runoff that you have to plan for. So you'll see throughout the next few pictures a whole bunch of shots of drainage and things that had to happen. But you know, here's the foundation, and then you have to think about getting equipment in there and the roads required. But again, drainage, really critical thing, and foundation, do that well from the beginning. We got kids involved. I got my nephew, my children involved. This gentleman here, Bob, was a fantastic teacher, and he and I basically built the whole thing. I'd say he built most of it, and I was his assistant. I learned a lot, and I'm thankful. The kids learned a little bit about welding and a whole bunch of other things in construction. I cannot say that we are going to win any safety awards throughout this process, but we tried to have a good time, and you can see it on the kids' faces. So we continue construction, building this wall, putting in drainage, etc. We put in a geothermal array, really a slinky system. You can see it going in the sand there, and then continue to bury on top of that. And as I learned, as you bury more and more behind that wall, you need, of course, bigger equipment to do that, and that costs more money. But eventually we got that done. Then we were working to get the slope of the roof lined out. And then we started painting, and from there things started to go a lot quicker. I kind of see the end of it coming together with the aluminum and the polycarbonate going on. I have a great respect for people who work on roofs now, because after being up there and screwing all those things down, it was difficult. So this is as clean as the greenhouse will ever look. Here I'm getting ready to put the barrels together. Barrels, you paint them blue so that they don't absorb algae. We have vents on the top, but you got to clean them out and make sure they're not leaking, which they're not. And I was relieved about that. And then we're talking about the roof vent system. These are motors and that tie into the controller that take that roof vent up and down depending on the temperature. Very cool system. I really like it very much. I'll talk more about that later as well. Okay, so one of the big mistakes I made was water pressure. So when we put these barrels, they're about 8 feet above the ground, the bottom of the barrels are. And that's not enough pressure to make stuff happen inside a greenhouse. The hardware store people would tell you more like 40 feet, okay, to get pressure like your house. So I was in this problem, I've got all this water and we can't use it very well like drip irrigation systems. And so I came up with this idea, it's kind of interesting. First I tried to make it work by using the 1-inch pipe, which is around all the greenhouse and the black pipe, you'll see that. And when you take 1-inch pipe and come to a regular nozzle, you don't get much pressure. Basically the resistance of the 1-inch, and then if you go down to a 3/4 inch standard garden hose, you just don't have very much flow there because of all the friction. So using industrial compressed air knowledge and other fluid mechanics from physics days, I thought of this idea, which has actually worked out pretty well. Is you take the 1-inch and you go into, I call it a booster, but it's really just a 4-inch pipe. It's non-pressurized. It goes up kind of high, the same height as the top of the barrels. And basically the water goes in this 4-inch cavity, and then you have a hose coming out the bottom so that when you connect this hose with not much resistance in that 4-inch pipe, you get a pretty good flow, much greater than the other 3/4 inch approach. Just the resistance so much less. Plus, the volume of water is significantly more too, so you can water a lot of plants really quickly. And this is all rainwater, so it's essentially free. But this has kind of been a fun idea. This is a little bit non-intuitive. A few things I learned over the first winter was we insulate all this stuff, because if it does get 31 degrees in here, we definitely don't want that to be freezing. And if we put heat tape on here as well, you can see the heat tape wrapping around. But this has worked out really well, and I'm optimistic that I'll be able to continue to do drip irrigation systems in here, and that will be like free water. So that was kind of neat. Now this is a 4-foot deep, 5-foot wide by 16-foot long cold sink, and I'm going to explain how this works. Here's the completed cold sink, and you can see it's not just the dead space. We use it to keep plants on. These are kind of grates you would find at an automotive like Jiffy Lube type store, so they can hold a lot of weight. They're made out of fiberglass, but this allows cold air to go through the gate, rewarm itself in the wintertime, and then come back up. A lot of people wonder what this is, but this is a tunnel to the inside of the greenhouse. The original idea was that we'd have bunnies and rabbits and maybe chickens able to come out here and run around in a caged area and get some outside time and then go inside. We didn't end up doing that, but it's an interesting idea, and the other benefit of having this here is I can use this for geothermal further cooling as well. These are cold frames which get pretty warm and also serve as another insulation barrier, which you might need in the wintertime. Our first winter in this greenhouse was very interesting. We learned that we weren't quite as sealed as well as we needed to be. It got kind of cold inside the greenhouse. You can see it on the red of this graph here. So I caulked up the seals, put in some other technology, put in some heat tape, and insulated the water pipes a little better. Another thing this winter I'd like to implement is this GeoThermal Ready system. So this is 3/4 1-inch pipe, something I can't remember. Anyway, it's 2 pipes going into the ground, and there's a loop that goes behind all this wall back here. And in the wintertime, I'm thinking if it gets cold in here, we can put a kind of an air handler with just a very basic coil and fan, and pump the water through the ground. Have it heat up, come out, and give that energy to the coil with a fan over it, and keep this area from freezing. That's the plan. So we'll see how this goes this winter. Another idea to increase the thermal momentum was to add more water storage. So this is a 275-gallon water tote. Really, it's an abandoned food container from a factory. Getting it up there was super fun. And you'll notice we paint all the barrels blue. We draped plastic over, black plastic over those totes to keep them from growing algae as well. And these are just progression slides showing how the greenhouse has moved along. Something I probably didn't explain as well earlier is the water barrels and all the totes, they're on the left-hand side. That's the north side of the greenhouse. So sun comes in from the south side, heats up those water barrels, and that re-radiates out at night, which is helpful in the wintertime. And in the summertime, also helps keep thermal momentum being cool. But just to the right, above all the plants in the middle of the picture here, above that I-beam, we really could use that space for vertical farming because we could use the I-beam structure to use pulleys and pull plants up in trays. A lot of opportunities there. So as far as winter goes, I think we're going to be completely fossil fuel neutral and get plenty of sun and solar thermal energy stored there. But in the summer, we've now got to reflect some of that heat away. So you can see the red lines here indicating how the summer sun's going to hit the greenhouse. And this clear panel stuff was not going to be helping us in the summer. So we decided to paint that white, which would get more reflectance and also give us some benefit on the solar panels, which are right next to them. Probably the most dramatic impact on solar heating was putting in this solar shade cloth. This is aluminum mesh. It reflects off 70% back to the atmosphere. You can take it off during the wintertime and leave it on during the summer. It's fantastic. Another thing that's helped a lot is a very simple solar panel hooked up to a DC fan. If the sun's out, the fan goes faster. If there's a cloud, it goes slower. And you can hear the fan dialing up or dialing down. If the sun's out, you get more exhaust air pushed out of the greenhouse, which is helpful. And in the winter, when that vent is closed, this will also be a good circulating air system. I know my wife's going to love this picture, but I want to make the point about when you design these systems, it's a good idea to try to think about how you're going to maintain them, because all of these things are going to fail eventually. So whether you have I-beams to stand on or you create ways to get up there with ladders, one thing I did that I thought was kind of cool was we put a rail along the right side of that building so that we could lay a board across the rail and the I-beam if we ever needed to maintain any of the moving structure of the vent or the fan or whatever. And that's been very helpful. And here's an example of just cleaning one of the barrels or drums. Being able to stand on something like a scaffold or a board between two I-beams or no board is useful. So enjoy that. The solar powered fan up there, DC, that's just pushing the hot air out. It makes a tremendous difference. But check this out, when I want it to get cool in here, this controller, if it ever hits 85 degrees, this is what's gonna happen. These misters turn on, and there's a lot of mist. Ugh. It's like a mist wall right there and up there. And basically that fan, the evaporative, latent heat evaporation, basically cools everything down real quick. And then the exhaust fan over there sucks out the hot air again, also in a little more rigorous fashion. But anyway, it's you can see that mist is blasting all the way over here. It's just like a big wall. You can see the dip downs in this graph showing where the temperature is dropped when that misting system is turned on. Also, you can see the relative humidity has gone up. It's kind of interesting, and it's actually kept the greenhouse cooler than it was outside. This is the controller that opens the vents and turns on the misters. It's really pretty simple, but a really neat system. And you can adjust a lot of things on it, like whether you want the thing to do automatic or open, and you can program at what point you want different doors or vents to open at different temperatures and close down, so that this thing in the fall and spring can pretty much run itself. You can pick all these variables of how many degrees it has to be before something happens, how long it waits till it samples again, etc., etc. Pretty useful. So this is showing the plexiglass doors shutting, and they are heavy because they're plexiglass, but you can see it hitting this limit switch and slowing down and then sealing really nicely. One decision that I've reaped a lot of benefits from was putting the internet into the greenhouse. Now it has to be in a waterproof box, and you can see the transmitter. So we could have like TVs and other things in there eventually. And this might be a good, improving the house value, because if someone else buys the house and wants to use it for other than a greenhouse, they're set up. Now this lower left-hand corner is this little white box. That's like a little transmitter for temperature sensors and humidity sensors that are throughout the greenhouse. One of them is right next to the main controller, so I can kind of double check numbers, and that's handy. They're numbered 1, 2, and 3. The second one is inside the greenhouse near the south wall, so I can monitor if that gets cold, and one's immediately outside in the cold frames itself. But what's neat is these number 1 smart thermometer, 2, I can scroll through on my phone and see the temperatures of each one and see if one is in risk of freezing or one's too hot, etc. And then I can use the camera, you might have noticed that in the picture too, and control the garage door opener, and then actually, on the camera, see a real picture, see if doors are open, and I can see in real time that garage door is now going to close since I asked it to close. That's been very handy and helpful. And just a little bit more on the controls and monitoring. Being able to see the temperature on a day-to-day basis and the relative humidity. You can even set these things up so they give you alarms if it gets too hot or too cold, and you can go back in time and look at certain dates. Very helpful. Another thing people are interested in is how to hide a 1,200 square foot greenhouse. So we didn't want to have this view from our pool, so you can see how we had to build up the wall partially for earth berming, and then we added decorations and drive it, and including the ridge line there. As you would look at it from one view, which very few people see, and then if you come around to the pool area or the place that most people see, it really is nicely disguised, partly because of that ridge line. And that whole approach worked out really well. It even disguised the solar panels, which I think turned out pretty nicely. This is the final part of just talking about the solar project, from how we did this, protected it from weeds, etc. And these slides just show the progression of how that came to fruition. I really like the solar panels. The gravel reflects back, and actually these are bifacial panels, so they will take energy off the bottom of them as well. And that white gravel, as well as the white north-facing part of the greenhouse, really contributes to those solar bifacial panels and good reflectance. But you have to do these kinds of things, lay out the solar alignment to make sure your panels are going to be productive. So all in all, this has been a really fun project. I will say that it is still a work in progress. I know very little about plants. My wife is the plant expert. I just built the building, and I can say that based on the performance of the building, we continually alter the building so that it gets better results for the plants. And of course, there's always things to fine-tune. On the solar panel side, that stuff has been no maintenance and just basically a great return on investment. So in conclusion, I learned a lot through this project. I hope you've gotten something useful out of the video, particularly avoiding expensive mistakes. And I hope it helps you live a fantastic life and save lots of money and help the planet at the same time. Thanks so much for listening, and have a great day.